Hello, we meet again in the episode of Hey, I forgot my assignment and my homework, now I need to revise and putting it on YouTube. Hey. So today we'll be learning on Fourier Sine series, which is one of my assignment questions. And the question is to find a Fourier. Let me see if I can click some. Oh, yeah, I can do this. Fourier series of phi is equal to x squared on an interval of 0 to L. So it's easy enough because we already have the formula that are given here, and all we need to do is just to find the b sub m and just substitute it back into the equation, the first equation right here, to find our phi x. Right, let's get started. So I guess we'll start by saying that our b sub m, that's a terrible m, b sub m is equals to 2 on L 0, and given our phi is equals to x squared, right? So x squared sine dx. We are basically done. We just need to figure out what the integral is by using the chain rule. Nope, not a chain rule. Just kidding. Hey. By the IBP, or the integration by part. It's easy enough to see. Yeah, I hope. If not, yay, future Rowan, you need to revise more. Yeah. So let u, by letting u is equal to x squared, and dv is equal to the rest of it, so sine m pi x L dx. And then what we do next is just integrate this thing right here. So it becomes v is equal to, if we integrate sine, right, we'll get negative of cos of the whole thing over the integration, what am I saying? the derivative of the inner part of cos. But I'm just going to write like this because it's easier to see. Yeah. Yeah, that's it. And then maybe for u, because we know that we're going to use du, just simply 2x dx. Right. Oh, sorry. If future Rowan don't remember, this is the formula. So if you have the integration of u dv, it's just basically is equal to uv minus v du. All right. Hey, so now we have, oops, wrong color. Now I have 2 on L is equal to all of that stuff, right? So x squared minus, I'm gonna write it neatly. So it's L, excusez-moi, minus x squared, of course, right, and we take the negative of integration of v, probably gonna write it a bit lower. Alright, what is our v? Our v is, because there's negative signs in there, so I'm just going to bring it outside, whoops, as well as the constant. So in du, so our du is 2x dx, right? But I can just pull out the constant. Awesome. So we're not quite complete yet, or we're not quite finished yet, because we still have one integrations to do. So just by the same procedure, we just let u is equal to x, this time just x, so du is just dx, and we take dv as cos m on L dx. Integrating both sides, we get what v is equal to sine of L m pi. Hey, yeah, so we're almost done. A little bit more. And I forgot this, we are integrating from 0 to L, as well as this one, right? So that will be, if you see here, if we plug in 0 into x, this whole term will become 0. So we don't need to worry about that. So we just need to worry about the the L, right? So that will become L cubed m pi cos of, substitute L into cos, inside cos, it will become m pi. Awesome. So I have 2L m pi, on the bracket here, uv. So that's a lot of writing of sine minus v du from L to 0. Yep. Okay. So if you're following, this is just uv minus v du. Yeah. Okay. All right. In some simplification that we can do is that if we plug in the limits from L to 0 for this one, right over here, it will become 0. Why? Because one thing is if we substitute 0 to x, so the whole thing in here will become 0, right? And then the other thing, if we substitute L, sine will become sine of m pi. And we know when we draw a circle like this, right? So xy or cosine, right? If you rotate along pi, so like 1 pi, 2 pi, right? The sine function will always be 0. So that means this will always become 0. Yay! Our life is easy now. So let's rewrite things that have been simplified. So that will become m pi cos plus 2L m pi, and we have minus. I feel like I did something wrong, but I couldn't figure it out. But that's okay. Maybe the future me, when I look at this video, I'll be like, hey, I know that's wrong. Alright, so if we integrate sine, we'll get just negative cos. So that's a positive here. Cos of m pi x on L squared, everything squared, right? Yeah, I'm hoping that I did this right. Okay, a little bit more simplification. So we have m pi cos of m pi plus, just put in, whoa, that's a terrible tree. Cos of m pi x L, and we are we're evaluating from 0 to L, right? We are almost done, and I said that is a million times already, but yeah, we are almost done. We just need to reduce this thing. Maybe we have 2. Yeah, distribute the 2. We'll get negative of 2L m pi cos of m pi plus 4L squared m cube pi cube cos of m pi. Alright, so now we found our bm, the value of bm, we just need to substitute it back in this equation to find that x squared is indeed equals to m larger than 1, where our bm is this whole equation right here. Just copy and paste. Yeah, whoops, multiply by sine of m pi x on L. So that's our final answer. Bye.